who don't know me, my name is Jin Chen. I'm the president of North American Catalysis Society. Welcome to New York, and welcome to NAM. It's such a great experience to see everybody in person now. So, yeah. I would like to, because we have all uncertainties due to COVID, I really think the local catalysis club really did a great job putting together a fantastic scientific and also social program. So I'm sure we're going to enjoy in the next few days. Now it's my pleasure to introduce and recognize the three co-chairs. So Professor Marco Custodi from New York, the City College of New York. Marco. And Professor Israel Watts from Lehigh University. And Dr. Lucas Therozio, so he told me it's just pronounced differently, so from BSF.
I told him he couldn't go wrong. I've heard it many different ways. So. All right, well, good morning, everyone. You know, it's, as I said, my name is Lucas Therozio. I work for BASF Corporation at the Catalyst Research Facility located not far from here in Iselin, New Jersey. And also for the last couple of years, I've served alongside Marco Custodi and Israel Wax as one of the chairs for the conference. So on behalf of the three of us and really the entire organizing committee, just want to wish you a warm welcome to the greatest city on the planet, right, New York City, and to NAM 27. As Juan said, it's really great to look out and see everybody here in person. And to be honest, the conference planning the last 2 years has been a bit of a wild ride, and none of us were really sure just how this was going to work out in the end. And I think one of the motivations that kind of kept us going right the last 2 years when things looked really uncertain was the opportunity to plan an event that was going to bring everyone back together again, maybe for the first time in 2 years. So here we are, roughly going to be about 1,400 of us for the week. I'm not sure we're all here yet. There's some delayed flights, but when everyone's here, it's going to be about 1,400 people, and we're going to be able to interact and collaborate like we did in the past, and that's just fantastic. And already last night, the opening reception, we've heard a lot of great things about it. We're glad that everyone had a really good time. But after the official ending time, everybody was still there, and that was fantastic, right? That's what we really wanted, and we made a literally last-minute decision to extend it an extra hour so that we could just keep people talking and interacting and catching up maybe for the first time in a couple of years. So it's great that everybody did that. It's exactly what we wanted to see. So from the entire organizing committee, again, it's a pleasure to have organized the event, and we wish you a very productive week. So with that, we do have some safety announcements. So, in the event, unlike the event, that there is an emergency or an evacuation, we will be meeting in this room quite often, and there's a large number of us, so we should just probably touch base on it. But we should go back through the doors that you came in this morning, and out to the escalators and down the escalators, and when you get to the bottom of the escalators, there's a door, and that'll take you out on 54th Street, and that's kind of the rally point for everybody in the building. So with that, I'd like to turn it over to Israel Wax, who will make a few more announcements and also an introduction.
Thank you, Lucas. So first, following up on the safety issue, I want to remind everybody that this is a masked conference. Okay? And this is according to guidelines given to us by the CDC and the City of New York, that for a large indoor event, the attendance should be masked. And we would like you, if you don't have a mask, there's ones downstairs, also by the registration desk. We have hundreds of masks for everybody, so there's no reason not to have a mask. I'd like to introduce our co-chairman, we selected Stu Solich from ExxonMobil to be the honorary co-chairman. And I'm happy to report that when it came time to select somebody to be honorary co-chairman, and this is selected from the local area, from the New York metropolitan area, that Stu unanimously stood out among any other potential candidates. And Stu has been at Exxon for decades. You can't imagine a time when he was not at ExxonMobil. And Stu has been a great scientist and has made a lot of important technological innovations. And also, with his experience, actually, oh, so there, great. Okay, so I didn't realize that they were showing Stu's picture. And Stu is also been a great mentor to the younger people at ExxonMobil and has played a major role in the New York Catalysis Society over the years. And finally, he's volunteered to be our photographer. So in the day, whenever Stu actually does decide to retire, we're giving him a new career to be a photographer of larger planets. Anyway, thank you very much. And Lucas will take over again.
All right, so this morning we're here. I mean, and really, this is why we gather each morning is to recognize, some of the contributions made by members of our community in the field of catalysis. And I really think, this is really the right forum, right? All together in person to go through this. And this morning we're going to be recognizing the recipient of the Hoodry Award. And in a moment, I'm going to be asking the co-chair for the session, right? To come up, Jeff Bricker, and he will introduce the speaker for this morning. But first, just to kind of set the stage and give you some context, I want to tell you a little bit about the person that this award is named after. So Eugene Hoodry, he was originally from France, born there near Paris. He received his mechanical engineering degree from a university just outside of Paris, where he won the gold medal, which means that he was ranked first in his class. His engineering skills after graduation was first applied in the French military, where he was a decorated officer in the tank corps. And after that, after World War I, he came back, joined his father's business. His father in the steel business. And he joined him as an engineer, but he had a passion for racing and fast cars and making cars faster. And he quickly made the connection between the quality of the fuel that went into the engine and the performance of the engine and how fast that car went. And this is what really sparked or maybe catalyzed the next 30 years of his life, right, in developing and commercializing new processes for the production of high-quality fuels. Initially, that work was funded by the French government, right, and the French government asked, he worked on converting coal to gasoline, which was a technical success, but economically it wasn't competitive. So that funding was pulled back, and I think we can all appreciate that kind of situation. But he kind of persevered, was invited to come to the United States and demonstrate his work, took the learnings that he had from that project, applied them in the United States, and ultimately that led him moving his lab to Paulsboro, New Jersey, which, if you're not familiar, is a town just across the river from Philadelphia, and just a few miles north of the Marcus Hook refinery, which at the time was owned by Sun Oil. And Sun Oil, after a few years of work, finally agreed to convert one of their thermal crackers into a Hoodry catalytic cracker, and it was a overwhelming success. Right? They significantly increased the production of high-octane gasoline, which for the time was a very big technical milestone. So through the 1940s, this process became widely adopted. They started building manufacturing plants for catalysts, and that was just in time for World War II, where he continued his support of the war effort, developing new fuels and supplying high-quality aviation fuel for the war effort. And but then after World War II, he turned his attention to something else that was starting to bother him, which was the health effects and the environmental implications of the fuel that was combusted in the engine. So he started thinking about ways that he could use the catalyst to clean up the exhaust of the automobile, and that led him to developing one of the first catalytic converters for an automobile. And ultimately, he received one of the first patents in the field in 1956. Here we see a picture of Hoodry in one of his favorite Bugattis, right? So this is the race car that he used in France during his early work. And today we would take the engine off this beautiful car and put it on a test stand and maybe do more methodical work. But I think his application of testing was much more fun. You see the external gas canister that was mounted to the side of the car. He could put his experimental fuels in there and then test how far or how fast the car would go. So if you're not familiar, the Hoodry Award has been given out for about 50 years now, almost exactly. And it's recognized achievements in the application of catalysis, and here we see a list of past recipients of this award. I think we'd all agree that this represents a very distinguished group of our colleagues in our community. This morning, we're going to add one more to this list, and now I'm going to invite my co-chair, Jeff Bricker, up to the stage to introduce this year's recipient.
Thank you, Lucas. It's a true honor for me to introduce Dr. Dang Jan of Honeywell UOP for his Hoodry Award lecture. I've known DY since we were in graduate school together. He joined UOP after getting his PhD in inorganic chemistry and has risen to senior fellow at the highest level you can achieve in our company, and actually a level very few people have reached in our 100-year history. For his contributions for catalysis in aromatics, derivatives, and olefins. Specific contributions, he's invented and developed commercialized catalysts for alkylation for fuming and linear alkyl benzene on a large scale, and also advanced catalysts for aromatic isomerization and transit alkylation, cornerstones of the aromatics complex. And for that, he's been awarded over 100 US patents. He also was a key contributor and inventor in metal catalyzed dehydrogenation for light and heavy paraffins. We worked together on actually a long time ago. Something you can't read about DY is, he's been a tremendous mentor to young scientists and engineers at UOP, and he forged a strong bond with the new materials and characterization groups. And that really led to guidance on new zeolite materials needed, what kind of structures, what kind of structure function properties we need, and helped scale it as well. And to this day, he's not slowing down at all. He's working on two of our biggest new breakthrough technologies right now, and he can't talk about it. But with that, I'll introduce DY for his lecture on aromatic catalyst and derivative catalyst using zeolite catalyst. DY?